Hey guys, Chris here from CHASNZ. It's a very wet Saturday, but not cold, so there's no snow, unfortunately. I should be up skiing, but I'm not. But I thought I would do something that's almost as good as skiing for me, which is risk modeling or probabilistic risk modeling. So I'm just going to take you through a short session. Hope it's helpful. It's just meant as a little piece of light entertainment, but if you want to know more, my details will be at the end of the video. Let's get into it. Right, so I've set up this model, and this basically is the function. So the outputs are down here. So here's the overall average failure rate per day. So I'm interested in saying how many times does this task fail in terms of exposure. I've got some exposure information up here. So how many hours they're working, how many people are on site, how many workers are required for the task length, how many times do we do the task, and then I've got some triple point estimates, some minimum, likely, and max for each one. This area here, the failure sources, this is the stuff that you use the fishbone diagram through. And you actually start talking to people about saying, hey, what are the chances of having the right number of trained people? And they might go 25% is the worst. Yeah, that's as bad as it gets. But as good as it gets is 70% of the time we only have the right people. Machine, method, materials, we go through the same thing and get the collective wisdom. So 3 points rather than just a single estimate. So what we then do is we get the model. We're really interested in the outputs of this one here. So that's the average failure rate of the day, which is the average of these three numbers there for minimum, likely, and max. So instead of just having one deterministic type calculation, you can see we've actually got three and then an average of the three. So what I've done is I've gone into Copilot, and I've actually already got it to do the simulation, because what I did find was, although Copilot and Excel are quite easy on the memory, Clipchamp is terrible. So Clipchamp just kills my computer. So having them both run at the same time is disastrous. But you can see what I've done. You can see here's the input I used. So I actually have got a script. I can actually distribute the script if anyone would like it. Please perform a Monte Carlo analysis on cell G24, this one down here. That's the output cell. Each variable has a min, likely, and maximum. Limit the number of analysis to 20 to 5,000 simulations. That's just to keep it speedy. So it's going to actually do this 5,000 times. Give me a histogram of the results, so a bell chart, and a cumulative probability chart, and a tornado diagram, which shows the sensitivity of the variables to the output. Write the analysis to a new tab. So you can see it ripped through all that, did it all, and here is the result. So first of all, I might just make this a little bit bigger for you and get rid of Mr. Copilot. So you can see here that the mean failure rate is 22.1%, so that's the model rate. 95th percentile, so 90. That's saying that you're really, really confident that you've got a 95% chance that it's going to be about a 30% failure rate for the day, and only a 5% chance that it'll be 14%. And that there is actually modeled on what we call this cumulative distribution chart. So this one here, cumulative probability of failure. So I can go all the way up and down here and sort of say, okay, if I want 95% confidence, let's find it. There it is there. It's around 30% that you can have a failure. I'm 95% confident that I'm going to have a failure of 30% that day. You can see the bell chart. So that's where it's gone through and created those 5,000 simulations and plotted them. Probably slightly left-leaning, maybe. And here is the real gold here, which is the tornado diagram. So this is showing you where the sensitivity is in the model. And you can remember that here's all the variables here, and it's saying, look, the occurrence is obviously the big one. The more times you do it, the more risky it is. Then the task length. And then the other big one there is machine. So machine is actually giving you quite a bit of negative variance. So if you go back to the model over here, you can see that machine, we only had 30% for minimum, and as the best it ever gets is we only got 50% chances of having the right machine. That's quite risk weary. So what we can do now is sort of go back to the team and sort of say, actually, let's have a look at this. This seems to be if we look at the number of occurrences, obviously if we can eliminate and bring down the number of occurrences, that's a good thing. So using the good old hierarchy of controls. But if we can't do that, then let's work on these other things as well and see if we can get these percentages higher by doing things like actually going out and buying the right tools. So you always have them on hand, and see what that does to the model, because as you can see, it's quite influential in the overall result. You might want to look at task length as well. is it taking longer because these things are stuffing you up, that sort of thing as well. So a lot of this stuff might work in a bit of a virtuous circle when you start working on the things that are actually making this task not a good task. So yeah, so that's the Monte Carlo analysis. Just a quick version that I've just run there with this model. Just a couple of other small things. You can see there that I've got the enterprise data protection on there. So if you are writing your own data, make sure you've got this, that the data stays within your own confines. Of course, as well, you can actually pick the model that Copilot works with. I just leave it on auto. I guess you could play with it and see if some of these other ones do it faster, do it better. I'll leave that up to you. More than happy to share the script, more than happy to share these practice models as well. So what does this all mean? So look, what I would do is I would go and have a conversation. Did you know that currently there's a 95% chance of at least a 33% failure rate for that task exposure today? You might say it in slightly more plainer language than that. What? That's terrible. What's driving that? What can we do about it? Biggest driver is simply the poor selection of tools and the time it takes to do the task. Let's get a better tool then and see if it makes the task easier and faster to complete. Great. After we've got the tools, let's do the analysis again and see how much risk exposure we've reduced. So that's the kind of the sort of field experience. You can actually go out there and work with teams and show them actually how you can actually move risk quite easily by just knowing where the levers are, which is essentially what Monte Carlo analysis will give you in probabilistic risk analysis. So look, that's it, guys. More than happy to get in touch with anyone who's interested in this kind of thing or as interested as me. More than happy to help. There's our details there. If you think in the future we might run like a little clinic for doing this kind of thing in person, more than happy to do that. Or if anybody would like the AI prompt or the sample file as well, more than happy to do that too. Let me know. Cheers and have a great evening.